Okay, so as Rod mentioned, this is our predictive map. All of the red are the bedrock, and the yellow is where water has moved it. So the yellow is pretty easy to predict. You just, water flows downhill. Next slide. Okay, but here's the tough part. Wind. Wind moves a lot of sediment here in the Mojave Desert, and this is much harder to predict because it's all going to be about direction, and that changes with time. And so what's really important, and some of the data I'm going to show you today, is what have we learned about the transport of these fibers by wind to other soils where we may not expect it to occur. Next slide. So in order to explain that, I want to tell you a little bit about how surfaces out in the desert evolve. They start off with soils like up in the top photo there where you have a surface that's really irregular. That's an old channel where water used to flow. And if you give it more time, dust accumulates and it makes the surface very flat, and you form this thing called desert pavement, which I think all of you have seen. Next slide. What happens is that dust actually accumulates under the rock pebbles at the surface and lifts them up. And so you'll get a surface pebble on top, 1 class thick. And then underneath it will be this fine sediment that's just dust. And I think the next slide shows what that looks like. Well, this shows you if you move that surface rock off, you'll see the dust. And then the next photo shows how sometimes this can be really thick. Okay, so all of this is dust that has been deposited by wind. Go ahead, Des. Okay, and this happens all around the world. This is a site in Australia. You can see this sort of red color here. That is the dust that's been deposited. This is called a vesicular horizon. The reason it's got a different color is because it came from somewhere else. Next slide.
Oops.
Go back one, yeah. So what we did in collaboration with Dr. Dave Berry and some other scientists with the EPA is we sampled 6 soils in and around Boulder City with the idea of let's try to find out how much fibers are in these soils. And so we sampled 3 around town. It's a little inset there. You can see CS is Colorado Street. MK is the Martha King School. B4 is at the end of Adams Boulevard out here. And then we also did WC, which is part of phase 2 of the highway. We did the dry lake bed. And then we were asked to come up with a blank. Well, at that time, we had never had a sample yet that had not tested positive. So we went up to the Nellis Dunes recreation area because it's completely out of this basin, and there's no way there should be any amphibole fibers up there unless they blew there by wind. That whole basin is surrounded by limestone and sandstone. It has the wrong kind of rocks in order for water to move asbestos fibers there. So we hoped it would be a blank. In other words, it would be negative. And if it isn't negative, then we would know it was deposited there by wind. And one of the ways that we made sure of doing that is we actually sampled one of those vesicular horizons. So we sampled a dust deposit. Okay, and I'll walk you through what we did. The next slide shows the equipment. This is called FBAS. It's a fluidized bed asbestos segregator. It's a method to really measure tiny amounts of asbestos in the soil. We use it with a transmission electron microscope. And basically you put the soil in here, you blow air through it, and it picks up the fibers and all of the small particulates, and it gets blown onto an air filter, which then you put under the transmission electron microscope and measure, count how many fibers are there. And you can get incredibly low concentrations measured very accurately. As you can see here, 100 times lower than the detection limits of the polarized light microscope, which is the standard way, the conventional way of analyzing material for asbestos concentration. The next slide. Here's the reason why we care. We really want to measure very low concentrations because if you use the conventional method, the polarizing light microscope, you can get results that say non-detect. And yet we know that soils that have tested as non-detect can still generate hazardous concentrations of asbestos in the air. If you go back one more, Doug,
sorry,
to that one.
Sorry. Yep.
What I want, and one way to think about this is if we were to walk outside, it's not quite dark, it looks like, but if we were to walk outside a little later and wanted to look for planets in the sky using our eyes, we're not going to see too many planets. But the Hubble telescope is going to see a lot of planets. So that's the thing about this method, is it doesn't mean that the fibers aren't there, it just means that you're not seeing them if you use the PLM method. Okay, so then we can go to the next slide, and the next slide shows again Libby, Montana, and again, one of the important things they found out in Libby is that hazardous exposures to fibers can occur in outdoor air during yard soil disturbances, even when the soils test is non-detect with PLM. And you can see, look at those soils, they got grass, it's different than here. Okay, next. So here are the results from the highway, and all of the green color tested as non-detect with PLM. So don't think that means that there's no asbestos there. It just means that the polarizing light microscope didn't see it. Okay, next slide. All right, so here are our results. This is B4. This is the site that's at the end of Adams Boulevard. It had 44 million fibers per gram. Actinolite, which is the regulated asbestos mineral. This, if you can calculate that out to weight percent, it's about 4 weight percent. If this site was in Libby, it would trigger immediate removal action. Now you can't do that because how deep are you going to dig? I mean, this is rock, and it could go down a really long way. So probably there'd be a different mechanism, such as trying to cover this up. Because again, the whole issue is, if it's in the ground, it's not a big deal, but it's when it's in the air that you can get exposed. I guess we'll go on to the next slide. So the dry lake bed was the next highest. It comes out to about 0.2% weight percent. This would likely trigger conditional action level in Libby. It's right at the boundary. And again, it's hard to transfer our results to Libby because theirs is a vermiculite deposit, and what they mean by conditional level, they have data we don't have. So some of that's difficult to do, but one of the things to pay attention to here is this dry lake bed has almost every single kind of amphibole mineral we have. So it's a huge mixture. The next slide shows the next highest, which was the schoolyard. This would test as non-detect with polarized light microscope, and it had actinolite and magnesium hornblende. Actinolite's the regulated calcium asbestos mineral. The next slide is Nellis Dunes, which unfortunately did not test as a blank. I mean, it didn't test negative. It would measure as non-detect with PLM method, and it again had this huge list, had every kind of amphibole asbestos that we've yet found here. Next slide. This is the site for phase 2. Again, it would test as non-detect with PLM. It also had all the different flavors of asbestos, amphibole asbestos. And I think the next slide shows our last result, Colorado Street. It had the lowest, again would test as non-detect, also had a mixture of all the different kinds of fibers. So if we go to the next slide, here's the other thing. So Erinite is a fibrous zeolite mineral, and it's really toxic. There is a rat study that found Erinite to be 500 to 800 times more carcinogenic than chrysotile asbestos, and maybe about 20 times more carcinogenic than amphibole asbestos. The thing with Erinite is that when you use a transmission electron microscope, which is what we used in this study, you can't tell Erinite from another zeolite mineral called Erinite, because these two minerals have almost the same chemistry and the same mineral structure. But Erinite has not been studied for health, so we don't know if it's toxic. We know Erinite is very toxic, but because Erinite has similar chemistry and structure, it may very well be toxic. There's probably no reason to think it wouldn't be, but it needs to be tested. So why I'm telling you this is because we found this, but we can't be for sure yet until we do more testing which mineral it is. But this is not something we want in our bodies. Next slide. So we found it in 5 of the 6 sites. And the dry lake bed had the highest concentration, and then it went in order. Nellis Dunes is next, then the school, etc. Okay, next. All right, so this gives you an idea of the overall kind of data set. The yellow is the sodic amphiboles. These are similar to what's in Libby. The teal colored are the calcic amphiboles. That's the actinolite, the regulated asbestos. And there's a few that the highway found in rock right here that match up with the sodic. It's really close to the Wilson Ridge site, and there's probably a fault there allowing fluids to get that sodium in there, but we don't know yet. And then this little triangle here is a soil sample from the highway, which also had the Libby-type minerals in it. And then all these red dots are our samples. 4 of the 6 had the mixtures, and 5 of the 6 have the Erinite offer-type minerals. So what this tells us is that wind is mixing these different fibers together, and then they're being deposited on our soil. The next slide. And so the closest origin of these fibers to Nellis dunes are these bedrock and soils down here. Now it's possible that wind could have blown these from farther away, but this is the most likely because this is the closest source. And so that's about 22 miles. And I didn't show the wind roses, but it works. That is a direction that part of the year the wind does blow in that direction, sometimes very hard. And the concern here is if it can blow that far, there's no reason to think that it hasn't blown across the Las Vegas Valley, and that soils out here could also have concentrations of asbestos that would be similar to what we found at Nellis Dunes. And so this isn't a Boulder City issue. This is a Southern Nevada issue. Next slide. Okay. Okay, so now I want to compare it to Libby. So these are soils from Libby that were not contaminated by any mining or processing activities. So in other words, the asbestos is there solely because of geologic processes, just like here. Water or dust, glaciers could move the fibers in Libby. And so we're comparing the two, and what we see is that about 4 of our soils are very similar in concentration to what's found in Libby, and then 2 of them are significantly higher, the dry lake bed and at the end of Adams Boulevard. The other thing we can learn from this is that these soils here and here will test as non-detect with polarizing light microscope, and yet these 2 soils, A and B, when they're disturbed because David Berry did the studies where they disturbed the soils and measured, did any fibers get in the air? They did. And so that's the concern. Next slide. And the other concern I have is if those soils in Libby, below levels of detection with the PLM, can generate fibers in the air at hazardous concentrations, then what will our soils do? We don't have the moisture levels. We don't get the snow and the rain that Libby does. And maybe even more significantly, we don't have the organic matter. Organic matter is that nice black topsoil. When you have it in the soil, it makes the soil particles stick together. So then they don't go in the air. And we don't have that. And obviously we have less vegetation. So one of the concerns I have, and one of the questions that we really need to find out here in Nevada, is do Nevada soils emit more fibers with less wind or less strenuous human activity, or do they behave similarly? And we don't know that answer, and that's some data that we desperately need to get. Okay, so now I'll give you some of the highway data. This is pre-construction ambient air, and they measured it at all these little green dots. So most of them were measured around the highway. There is one here in Boulder City, and this is for last summer. So if you give the next slide. Okay, and so what you can see is some very high concentrations early in the summer, and then it got lower. There were 4 rain events over here, which lowered concentration. The other thing to note is that more of these monitors went online halfway through the summer, so there's more data over here at the lower end than there is at the higher end. The average is this black dotted line, and it comes out to 0.0002. If you go to the next slide, that's 2.3 times higher than the reference concentration that Dr. Berry just talked about. It's not enough to tell us, oh, you know, we're all going to get sick. We don't know that because it's just this one summer that got measured, and only for those monitoring stations. So what we really need to do is get this ambient data measured over a much longer time period. We need to find out what it's like in the winter. Particularly right now, we're in El Nino. And in El Nino, we tend to get a lot more rain here in the Mojave. So weather changes. We need to get the data over time and over a greater area to know. But I think this is enough information to tell us we need to take this seriously. I also wanted to point out what OSHA's permissive level is. You can see it's so much higher. And as the other speakers have said, OSHA admits this is not a health-based level. They know that there will be increased cancer and increased disease with that level. Next slide. And the Boulder City Action Group has been doing a lot of work. This is some of the newest data from online, from the monitors that are near the construction zone. And you can see that there are some data that's several orders of magnitude higher as well. Next slide. Okay, this is something else I wanted to point out and let everyone know that most of the blasting for the highway is going to be over here in the bedrock, up there. Not quite tall enough to point it out. And one of the things to keep in mind is the average direction of wind at night for Boulder City is from the north and northeast. They're doing the blasting at night. So one of the things that you can do if you want to limit any dust that may blow into the city is keep your house closed up at night. Don't have your windows open. Next slide. Okay, so we really need to know human exposure. We need to know what are the exposures for residents, just not doing anything in the desert, and then what are the exposures, this is called activity-based sampling, for all the things that we love to do here. This is why we live here, one of the reasons we live here, you know, hiking and biking and your motorcycle and your horse and, you know, all these great things that we love to go out in the desert and do. We need to find out what are those exposures. And so I think some of the most important potential actions that can be taken now is Clark County should adopt the California Air Resources Board regulations for naturally occurring asbestos. That was voluntarily done for the I-11 highway, and so why not require it for all development? I think we need credible activity-based sampling data, and we need that very soon, because you all and I don't know what choices to make if we want to lower our fiber exposure. And the only way to find that out is to find out what is your exposure if you have a garden, if you like to walk your dog, if you like to ride your bicycle. And we need to get more of this ambient air data because, you know, maybe it's only when the wind blows from the south, maybe it's only when the wind blows more than 10 miles an hour. I mean, there might be ways for us to, well, I'm sure, I feel very confident that there's going to be ways for us to live with a naturally occurring asbestos. In fact, the next slide, you can write this down. This is the short link. There are a lot of people who live with naturally occurring asbestos. We are not the only community with this. But in order to live with it, you need to learn how you're getting exposed. And that's what we don't have. And there are a whole bunch of mechanisms that you can take now to decrease your risk. These are found by the EPA and the Agency for Toxic Substances and Disease Registry. We have them on the link. There are things, you know, like wiping your feet before you come in, those sorts of activities. So those are things you can do right away. Go get those links and read about them. But then what we really need to do is we need to get that activity-based sampling. The EPA could do it. The state would have to ask the EPA to come in. The state could do it. And by the way, I'm not asking that anybody hire me to do it. I am too busy. I don't need any more work. And frankly, I've had some experience doing it, but the people who need to do this, in my opinion, are those who really know how to do it, and they're the ones in Libby. And so I personally think that whoever it is needs to get them in here and get those measurements so that we can understand where our risks are and what we can do to lower them. I mean, for example, I have the red-haired gene. I have a very high risk for skin cancer. And I live in southern Nevada. Well, but I know this, and so I can take measures to limit my risk. I wear a hat, I wear long sleeve shirts. I don't go out in the middle of the summer or, you know, the middle of the day. And I think we can do the same thing with naturally occurring asbestos. We can learn what are the behaviors we have to change so that we can still live here and live here in a more healthy manner. Thank you.